Yes, Narendra, you can go on. Narendra.
Okay. I'm waiting for the Javed to join the meeting.
Oh, he didn't join.
Yeah. I just send the link and I think we'll join in next 2 minutes.
Just call him and say that you can join the previous link by using previous links.
Okay.
Or just text him that meeting ID and passcode. You have
I
that
just
now?
yeah. I just
Okay, okay.
let me call him.
Yeah, please.
वीडियो कॉल चालू आहे मम्मी.
Guys, sorry to be a little bit late. The speaker hasn't joined yet. So very soon he will be joining, then we will go ahead.
So hello guys, good evening all. So Javed will be presenting his work. So Javed, you can go ahead and briefly introduce yourself.
Hello everyone. Am I audible? Hello.
Yes, you are audible. Good.
Okay. So thank you, ANC IIT Kanpur for giving me this opportunity to share some of my knowledge in this plotting session. So I will share my screen. I hope you guys have found the data file and one MLX file that I sent. Did you get that file?
Javed, put those file in chat box also, in case anyone.
Okay, let me see. So I am putting this file in the chat box. Just give me a moment.
Javed.
Yes.
So just I have seen you have sent that file in general group, right? On Slack. So for the next time, please send in that MATLAB Session channel.
Oh, okay. Yeah, there is one more.
So guys, you can find that file in general channel, and please download it as per Javed whatever he is saying, and then okay, he will let you know the further details.
So if everyone is ready, I can start. At least you should have this file, the MLX file that I put on chat right now.
Yes, sir. I am sending that file in the group.
Okay. Speaking. Hello.
Yeah, Javed.
Just a quick note. Please don't call me Javed or yeah.
Javed, your voice is breaking. Hello, Javed. Hello. Javed, unmute yourself if you are talking.
Am I audible now?
Yes, yes. So go ahead.
Yeah, there is some problem with the connection. Please let me know when you cannot hear me. Okay.
Okay, sure.
So I have to share my screen again, I think. Is it visible? Hello.
Visible now. Yeah.
Okay, so I will start by asking the question, why do we need graphs? So we need to visualize the one-dimensional numbers, because numbers in mathematics are purely abstract. So we need to make some kind of relation to visualize the number. For example, for one number, we can say that it is at some distance on the number. There are two numbers. Hello?
Go ahead, yes. You're audible.
Yeah, actually, it is giving me notification that my internet connection is interrupted. So let me know I'm lost. So with the pair of numbers, we can have something called coordinate system. It's like two number lines put perpendicular to each other, and on this coordinate system, we can just kind of visualize where a number lies. So it gives a visual representation. Similarly, if a number, if there is a pair of three numbers, we can visualize it on a 3D coordinate system. So, for example, if we have a function y is equal to x square, to visualize it, we need to plot the discrete value on the coordinate system. So we have y equal to x, where x is independent variable, y is dependent variable. We discretize the independent variable. So we take some discrete values. For example, here I am taking -5 to 5, which will give me value of is 25 to 25, and then we kind of put points and we can join the
Javed, your voice
points by a
breaking.
line. Okay, I think I will have some problem because usually in the evening this net connection goes bad. So what should I do?
I think close all the tabs. I mean, in the browser, if you are using Google Chrome and all that. If you are using in case, maybe they are using their internet.
Okay, everything is closed now. So should I move ahead?
Yeah, it's now clear voice. Go ahead.
Okay, so next is some common terminology in the graphing. So if there is a graph, we have some common terms that we will use throughout this session. So I thought to just introduce the attendants to them beforehand. So if there is a plot, we call something on the top figure y-axis, x-axis, and the label that we denote the. Generally, we plot independent variable on the x-axis. We denote that by x-axis label, and dependent on the y-axis, and the label is y-axis label. And then these lines are called grid lines. These tick marks, the bigger ones, major ticks, and the smaller ones are called the minor ticks. And if there are more lines, more than one lines, we denote them by some kind of symbols or colors here. For example, this blue one is the sin x, this one is cos x, and we call it a legend. So we will start starting with a simple graph that I think most of the guys know. So we take from -10 to 10, let's say, and we make y.
Hello, sir. Your voice is breaking. We can't understand what you are saying.
Okay, so and I don't know what to do because this internet is having some problem. Maybe the other speaker can go first if.
Yeah, I think so. Saurabh, are you there? Hello, Saurabh.
Hello. Yeah, I am here.
So you can take over. Take over.
I can take it.
Yeah.
Okay, so after the Saurabh, I will see if the connection speed is good.
Yeah,
Then
yeah.
I
You
will.
can. Then you will continue. Sure, sure.
Uh, 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 Hello, Narendra. Should I start?
Yeah, yeah. You can start.
Okay, so I will be able to share the screen, right?
Yeah, yeah.
Okay. So everyone, hello. My name is Saurabh, and I'm a PhD student in Department of Civil Engineering. So I will be sharing. I will be covering the following topics. Okay. So these are the topics that symbolic calculation. It will include the differentiation, integration as well. Then I will move on to curve fitting. Then we will cover optimization. So what does symbolic calculation do? Basically, it provides function in the common mathematical terms, such as calculus, linear algebra. So basically, whatever equation that we used to write, right, x square plus y plus something equal to z, okay, and then we used to solve it. So we will be able to do the same in the symbolic calculation using symbolic toolbox. Okay, so if you want to see the documentation, you can just type help symbolic. Okay, and to perform symbolic computation, sims is used. Okay, so we will be seeing some common use. Okay, so let me share the MATLAB screen. Why am I not able to share MATLAB? Okay. So are you guys able to hear me, right? Hello?
Yes, 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 sir, yes, sir.
Yes, sir.
Yeah, because without any response, it becomes quite problematic. Okay, so just let me show you some brief examples. So we have to use sims to declare the variables. Okay, suppose I declare x as a variable. Okay, now I can write any equation such as y equal to 5 into x square. Okay, or r equal to 2 into x to the power 5 plus 3. Okay, and you can see the output in right beside me. Okay, see, we can see the output. Okay, that y equal to 5x square, r equal to 2x power 5 plus 3. Okay, so we can do all, we can also perform arithmetic equations, uh, basic equations such as addition, multiplication, division. Okay, such as y plus r, y divided by r. Okay, equal to y into r. Okay, so you guys can see that we have done perform multiplication, division as well. Okay, so these are some of the very basic use. Okay, also you can see that we have written u equal to u in the form of 5x square into 2x to the power 5 plus 3. We can expand it also. So we for to expand it, just write expand u. Okay, so see, now we have expanded it. Okay, so using that you can try to simplify very complex equations also. Okay, and it is not necessary that you only define one variable. Okay, you can define a lot of variables. Okay, for example, you can just x, y, z, t, whatever variables you can do. Okay, I have also done some basic examples. You can see here, these are the same I have seen. Okay, one of the basic useful thing that we can do using symbolic calculation is that we can use it in differentiation as well as integration. So if you want to differentiate any function, suppose we want to differentiate r, which is 2x to the power 5 plus 3. So you can just define any function v equal to diff then r. Now if you write just simply, if you are writing simply diff, okay, so it will only differentiate one time. Okay, dr by dx. Okay, but if you want to do it multiple times, just let me do it for one time. Okay, so you can see that 10 to the power 10 x to the power 4. Now if you want to do it more than 2, let's make it 2. Now it's 40x to the power 3. Okay, so it is quite useful in there. Okay, that if you have some problem that you have to differentiate it single time multiple times. Okay, we can see we have done some problems like if you want to find minima. Okay, so you have to differentiate it twice. So you can do that in here. Okay, as well as if you want to integrate. Okay, so you can just write w equal to integrate v. So if you just write simply integrate, then it will be a hello. It will be a indefinite integration. Okay, so if you want to do it a definite integration, you will have to provide limits like 0 to. Okay, so now if I am doing the integration, then we are finally receiving a value. Okay, like w equal to 160. Okay. Uh, yeah.
Can you
Yeah.
can you go a bit slow, because you are saying
Okay.
that.
Okay. Yeah. If you are having any problem, please say. Okay. I'm.
Hello, sir.
Hello, sir.
Yeah. Sure. Hello.
Hello, sir. I have written this program in MATLAB, but still the right screen is not showing in my case.
Okay. So I am using a live editor. Okay, so that I can see it in the right hand side. Okay. It's not my preferred method, but I'm using it for that everyone can see what is happening right beside. Okay.
Okay, sir.
So if you can also use live editor. If not, you can just simply use this M file. Okay.
Sir, how to open this live editor?
Here, see, open. This is script, live script. Okay. So you can use this live function. Okay. So this is basically this. Okay.
Okay, sir. Thank you, sir.
Excuse me.
Yeah.
Yeah, I have a question that this SYMS X, we have declared X over here because X is a dependent variable. So all the dependent variables you have to declare before using it.
X is X is an independent variable. Okay.
X is independent.
Yeah, sorry. X is an
X is independent.
Yeah.
Rest all Y, R, S, T, U, V, W. These are, we can say, those are dependent. Okay.
And the differentiation function that you have shown here is with respect to X, right? The function that we have declared, the variable that we have declared.
Yes.
Okay.
Yes.
In case we have
So
declared multiple
if you have
variables, how will it decide?
So if you have declared multiple variables, then you have to write here X. Okay.
Okay.
You have to declare the variable here also. Okay. So right now I have just written diff R with respect to X, then 2. Okay. So suppose, let me just clear X and Y. Z equal to yeah. So here you can see also, hello, that you can see I have declared X and Y as a variable and Z as a function. Okay, 5x square plus Y. Okay. Now since we are differentiating it, then v equal to 10x and v1 equal to 1. First one is differentiated with respect to x, then second one is with respect to y. Okay.
Yes.
So you guys are following me. You are guys are with me, right?
Yes.
Right.
Yes.
Okay.
Sir, if you want to differentiate with the both variable, then how could you do? The first with the x and then after.
Yeah, if you want to do it with one after the next, right?
Right.
So just write then put v from here to here. Okay. We have learned in maths, right, that if you have to perform a double differentiation, then we first perform the differentiation using the first variable, then we go to the second variable. Okay. So either you can write it like this, okay, or You can just write v2 equal to diff. Okay. You can go some complicated version here also. Okay. Z x comma 1, then whatever the function will you will obtain, you have to differentiate with respect to here. Okay, so it's slightly a bit complicated if you are trying to write multiple things in the same way. Okay, you can see it here. There is a lot of chances to make a mistake here. Okay, so I will recommend that try to be as write the code as simple as possible. Okay, if you are going right, see here, it's becoming an error. Okay, so we have to be careful about that. Okay.
Okay. Excuse me. Yeah. So what does this one represents in the expression v is equals to differentiation of function?
One represents the number of times we are trying to differentiate. Okay.
Okay. And does the sequence changes the expression, like if we put x in place of z and z in place of x, so does that change the will that change the?
No, it doesn't matter.
Okay.
No, it doesn't matter. Okay. You have to be careful about what you are declaring as variable. Okay. I have declared x and y. Okay, because we are very comfortable with x and y, right? So because that is why I have used that. You can use any variable. Okay.
Okay. All right. Thank you.
Okay. So these are some of the very basic problems that we have seen. Okay. Now we can move to some fun stuff. Okay. These things everyone can do. Okay.
Saurabh,
You can do it on hand. Okay. Yeah.
Saurabh, yeah, doubts will be cleared after
Yes,
the session. So just cover the part, then we will discuss the doubts because
Yeah,
it will
sure.
take the time.
Now, yes, sure. So let me show you. You can also use it to plot. You can also use to plot your functions also. Okay. So let me show you. Okay. So here I have written a function. Okay. And I have also used substitution. Okay. Suppose in problems that we have to substitute from replace x to x plus 2. Okay. So here I have written p, and this is my function. So here in f1 I have replaced f2. I have replaced x, say x2 x plus 1. Okay. In f1 I have replaced x to x plus 3. Okay. So here you can see, right, we have q, right, 2x cube plus 2x plus 2. Now I have replaced x with x plus 2 and x plus 3. So you can also use subs to find the value. Okay. Suppose we have any problem, like we have this q, right, and we want to know the value of q at any particular point. So val q equal to subs q and x at 3. Okay. So here, guys, you can see in the command window, value of q is equal to 62. Okay. You can check, and also we can plot our values. Okay. I have plotted this 2x plus 2. Okay. So here we can see. So okay. Let me show you. Okay, so here we can see the function. Okay, that I have plotted 2x plus 2. Okay, so here you can replace it with any function. Okay, it will be the same. Okay. Now we can also use symbolic calculation to solve equations. Okay, so let me show you some very brief example. Okay. 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 Here you can see. Okay. The polynomial equation that everyone has solved. Okay. let me just take it here. Okay, so I have declared a, b, c, and x as the variable. Okay, and ax squared plus bx plus c. So if I am trying to solve it for x, okay, so here you can see the following solution. Okay, so we can use this. You can use similar type of solution to find your solution to any problem. Okay, so let me write any general equation. Okay, since we will be solving only for single variable, so x square plus 6 plus
Excuse me, sir.
just take, yeah.
Sir, sometimes when I'm using SYMS, it is showing that there is a requirement of symbolic maths tool. So we need to
Okay.
download it.
Yes, if you don't have it, then you will need to download it.
Okay.
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 Yeah. So okay, so here I have written an equation: x square plus 5x plus 6 equal to 0. Okay, we have to put equal sign 2 times. Okay, otherwise it will show you error. Okay, now I'm trying to run it. Okay, so we have the following solution: -3 and -2. Okay, it should be -3. Yeah. Okay, so you can solve it for any other type of problems also, like you're trying to solve exponential problem. Okay, exponential. Okay, so if you are trying to solve it, so this is just a random W naught is Lambert. Okay, so it's okay, so it's not a real solution. It will give us to a complex solution. Okay, so we can use this for solving linear problems. Okay, we can also use it to solve a system of linear equations. Okay, so I have prepared some question. Okay, so you can see here we have a set of linear equation. Okay, x, y, z. So we can write the equation 2x plus y plus z. Okay, equal to
Excuse me.
2. Yeah. Hello.
Yeah, in the last part, there was a W naught in the
Yeah.
solution. What does that mean?
W naught is Lambert W function. Okay. W naught is a Lambert W
Is
function. Yeah. It's
that
not.
is that some value or?
It has some value. Okay. You can try to find it in detail. Okay. Even I don't know what that is. Okay. So
Okay.
yeah, I have just taken a equation just randomly. Okay. So I cannot really say that the equation that I have written really have a solution or not. Okay.
Okay. Okay. Fine. Fine.
Yeah, but you can use this. Okay. It's not any problem. Okay. So you can just write it as cos. Okay. Then we can have have a completely different solution. And it's not necessary that this problem will have a solution, because I've just picked up at random. Okay. See here, unable to find any explicit solution. Okay. Okay, so now I can see we can solve a set of linear equation. Okay, so solving a set of linear equation we have already done, right? In MATLAB, you can just directly use in matrix method. You can directly use it. Okay, so this is another way to solve linear equations. Okay, so just write your equation as 1, 2, 3. Okay, then we have to convert them into if we are using lin solve, then we have to convert this equation into matrix. Okay, here you can see I have defined a and b, and just equation 1 and 2 and 3, and variable x, y, z. then we can solve directly x equal to ln solve. And but if we are trying to use the solve, then we can just directly use it. Okay, so we can, I am running the question. Okay, so you can say this is the matrix form of the equation, this is b, and the resultant x we are getting, and this is x is from the ln solve method, and this is from this solve method. Okay, so similar to that, you can use you can try to formulate any different type of linear equations. Okay, and one advantage is that if we have like if you have multiple variable and you don't have any enough set of equation, then you can just write that variable also, and it will solve that in terms of that variable. Okay, like if you have three variables, only two equations, so whatever the answer you will receive will include that variable. Okay, now let me move on. So uh, we can also solve we can also solve differential equations. Okay,
Excuse me, sir.
yeah,
So, sir, could you share the files in the chat box actually, as the things are going quite fast, so we can't keep the pace with you.
okay, let me show you. So I will upload the codes also. Okay, that will be fine. Okay,
Okay, sir. Thank you, sir.
yeah, at the end of the session I will upload the codes. Okay, okay, let me, I have shared the codes. Okay, not everyone. Yeah, I've shared the codes. Okay, so that will be fine. Okay, now okay, so you can see here I have prepared two different problems that I will be solving using symbolic toolbox. Okay, so the first differential equation is 2x into d2y by dx square plus 3x dy by dx minus y equal to 0. Okay, so this is a sample problem. Okay, not necessarily that you cannot use any other equation. Okay, it can be degree will be order and degree can vary. Okay, and there is another equation that I will be solving. It is a set of differential equation. Okay, so let me move on to the code. Okay, so if you want to solve the equation, okay, if you want to solve differential equation, okay, so let me write the equation. Yeah, so I have to declare sims. Okay, now for the first equation, y is a function of x, so I have declared using that. Okay, so y is a function of x. Now I am writing my equation equal to diff yx twice plus 3 into x y equal to 0. Okay, so this is my equation. Okay, So to solve it, we can use tsolve. Okay. I think, yeah. So okay, yeah. So let me just solve it. Okay. So this is my equation. Okay, you can see here, and code is running. Yeah, yeah. So it's completely. Okay, let me just modify it. Yeah, so you can see here the equation is 2x squared d2 upon dy upon dx square minus y plus 3x dx dy by dx, and the solution is okay. So in the solution we have some constant term. Okay, so for that, to remove that, we need to provide conditions. Okay, so for conditions, prepared to condition. Okay, so for the first condition, I have that for x is equal to 1, y will be 1, and for y equal to 9, for x is equal to 9, y will be equal to 3. Okay, so when after we solve this, okay, so yeah. Yes. Okay, so our finally my final solution is y equal to root x. This will be my final equation. Okay, so you can try to variable. You can just try to solve any other equation also. The best way to do it, just pick out your maths book, okay, and just solve all the problems using symbolic toolbox. Okay, so we have a lot of differential equation in those problems, right? So you can solve all of them. Okay.
Excuse me.
Yeah.
Yeah. Why is the expression in the sixth line required? CONDS equals condition 1 and 2.
These are the conditions. Okay. So right now the original solution we have written we have got the original solution as constant divided by 3x plus constant into root x. Okay. So C6 and C7, these are the constants. Okay. So to remove those constants, you need some boundary condition, right? So some kind of initial condition. So we will require those conditions. So that is why I have provided uh, at y at 1 and y equal to y at 9. Okay. So when we provide those conditions, we finally get our equation as root x. Okay. I hope it is clear.
Sorry, actually, I asked why the sixth line is required. We have already given the conditions, boundary conditions.
Yeah, no. Sixth line is required because I have to combine both this condition into a single variable. Okay, I can also remove this line also, but I have to just instead of here I have to provide here. Okay, so when we write our so when we write it here, so basically tsolve is a function. Okay, and these are our input parameters. Okay, so we have to provide all the boundary condition into a single variable. Okay, so I am trying to make it more detailed. Okay, so that there is less chance of error, because usually what happens that we are writing any function and there's a mistake here and there, so it's become a bit problem to search for that problem. Okay, so you can see here we can easily solve any differential equation. Okay, uh, you can try to verify, you can try to modify it also. So I have modified the problem. Okay, don't know really whether it will solve or not. Okay, so this is the problem. Okay, so it is not able to find any solution. Okay, so we are not able to find the solution for this kind of problem. Okay, So now I will move to the how we can solve a set of differential equation. Okay. So I have already shown everyone the equations. So these are the set of equation. Okay, du upon dt equal to 3u plus 4v, dv upon dt equal to minus 4u plus 3v. Okay, so I will be solving this set of equation. Okay, so here we can see, okay, similar to previous. Okay, define u and v as a function of t. Okay, so first equation is there. Okay, second is also here. Now I have combined both these equations single set. Okay, similar to previous one where I have put this condition to single one. Okay. Now the solution that we received, it has constants. Okay. So we need to provide some boundary condition. Okay. Now after that we can solve it again. Then finally we receive the values. Okay. Sine 40 e to power 3x as u and v. Okay. So you can try to increase the number of variables. Okay. But it will the process will remain same. Okay. You can make it here like it's cos u. Okay. And here it can be sine. Okay. The process will remain same. Okay. You have to see whether the equation is solvable or not. Okay. Here the equation doesn't have any explicit solution. Okay. So yeah, but the solution type will remain same. Okay. The best exercise will be that just pick out your maths book. Okay. And solve this type of problems just simply using MATLAB. Okay. We have all most of us have solved this equation, right, using pen and paper. So you can solve it using MATLAB and we can match. Okay. So this is the these are the many most of the functions. Okay. Let me show you something different thing. Okay. This is also a part of symbolic calculation. Okay. Yeah.
So here you have used fplot. What is the difference between fplot and a simply plot?
Okay. Simple plot is just directly plot. Okay. Fplot is using for a symbolic function. Okay. That the function that we have here. Okay. These are you can say it's not a part of in the plot. Like I said, the variable have to be a kind of matrix. Okay. Let me just check. Okay, because I have not used plot here. Okay. See if we are using plot, then what difference we receive. Okay. Yes. So here I am trying to use plot. Okay. See, for plot, the data must be a numeric. Okay. So it has to contain some kind of numbers. Okay. Double. You have to be a kind of double format. Okay. So we are not able to use plot here. Okay. That is why we are using fplot. Okay. There's some yeah.
Fine, sir.
Yeah. Okay. In some books you can see instead of fplot they have this ez plot also. Okay. Ez plot is absolute. That is become old and it will be removed. Okay, from the MATLAB. Okay. Now let me show you a different. So most of the things that we have seen here, we have typed it. Okay, but MATLAB also have this what we see graphical interface. So you can use that also. So the command is fun tool. Okay, so basically it will open this window. Okay, I think if you have tried it, see So here you can define your x, okay, like x square plus 2. Okay, so see here, the f will vary, okay, and you can perform many operations in this, okay, df upon dx, okay, simplify, okay, 1 upon x, okay. So
Sir,
it's a
your
great tool,
window is
okay.
not visible. Your
Uh,
window is not visible. Like only
Yeah,
MATLAB
window,
windows.
yeah. Can you share
okay,
the GUI window also?
okay. See, this is a fun tool, okay. I think this is a problem from Zoom, okay. So this is a fun tool, okay. So in F you have to write your function like x square, okay. So here from using that df upon dx, integer of x, okay. In gx you can also use provide any function, okay, and you can use any operation like f minus g, f plus g, 1 f upon g, okay, f of g, okay. So if you are writing this x square, okay, then let me show you the graph that you will be receiving, okay. So this is the graph that we receive, okay, for x square. So if we change it to some other polynomial, okay, 2x plus, so I've changed it to x square plus 2x plus 1, okay. Let me just, so the function is 5x square plus x square plus 6, okay. So we can see how the graph varies, okay. So if you have any problem, like, okay, how the graph will be moving, okay, so you can use this here, okay. So it's a very what we say, kind of a very simplistic toolbar, okay. It's very helpful, okay. Okay, so now I think we can move on, okay.
I have a question. You wrote some. There's in the code you wrote s dot v somewhere and s dot u somewhere. Is that dot means multiplication in the equations?
No. So in MATLAB, if you are using any dot some anywhere, okay, so it will it will show that the whatever the file, the variable is a structure, okay. I think you have covered a structure, right? What is a structure, right? Hello. So
I'm not sure if I covered that. Okay.
so okay, let me just show you. Where's MATLAB? Okay. So I think you are sharing here, okay. When here, okay, where I have solved, okay.
U sol t is equal to s dot u. This one. Yeah, both these
Yeah,
equations.
okay. So why? Okay. So the s that I am getting from solving, okay, here, okay. So the s is basically, s is a structure, okay.
Okay.
See here, the s is a structure, okay. So if you have to obtain any value from a structure, okay, so you have to write s dot u or s dot v, okay. So I think when you cover these 5 types, okay, variable types, then you can see, okay.
So say dot u and dot v will convert into a matrix form.
Dot u and dot v, yeah, it will be a symbolic form for the time being, okay. So if you want to convert into a double type, then you have to write double, okay,
Okay.
double into any variable, okay. So let me move on. So okay, so we have guys, we have covered this, okay. Now the topic is curve fitting, okay. So curve fitting is a very important topic. I think we all know, we have performed, most of us have performed some kind of curve fitting, okay. So let me show you in how we can do it in MATLAB. In MATLAB we have quite a very easy toolbar, okay. So if you want to receive, if you want to get the toolbox, you have to write this. Just write CFT tool. Okay. So are you guys are able to see this? Okay. Curve fitting tool.
No, sir.
Okay. Okay. Now you're able to see this?
Yeah, yeah.
Yes, sir.
Okay.
Yes, sir.
So basically here, this is a curve fitting toolbox. Okay. So here in X, Y, Z, you have to provide your data. Okay. And this is type of weights. Okay. Now here you have to provide what kind of curve fitting you want to perform. Okay. Interpolance, lowest, polynomial, custom equation. Okay. In polynomial, we have also a degree of X and Y. In the bottom that we can see, you have this, you will get this, what is the error of your curve fitting. Okay. SSC, R square. Okay. RMSC. So let me show you some, let me generate some random data. Okay. Suppose X is equal to rand 10 into 1. Okay. So this is just y I have generated randomly. Okay. Now I am just writing y equal to, sorry, no, write just x as a randomly generated data. Okay. Now y equal to cos x plus, okay. So basically I have added y equal to cos x plus some randomly generated data. Okay. So this I have done this so that there will be some kind of difference between y and x. Okay. So if we are just writing y equal to cos x and we have all the values of x, then the graph will be a very simple one, right? Now, so if we have to perform this, uh, we go to the curve fitting tool. You guys are able to see this, right? Hello.
Yes, sir. Yes, sir.
Yes.
Yeah. So here you have to load your x data, and then from y we can load our y data. Okay. So see, if we are having polynomial of degree 1, okay, and here we can see this. These are the linear order px plus p2. Okay, p1 and p2 are the coefficient. Okay, so we can see that the model is not a very good one. Okay, R square value is only 0.03. So we can try to modify it. Okay, now we have some, model has improved some. Okay, okay, again the model is not improving. So you can just try any custom equation. Okay, so y equal, if we have y equal to equation in this format. Okay, so again, now I have just written a model. Okay, y equal to cos x plus c. Okay, so you can see here uh, we don't have any, the R square value is not very high. Okay, because of the addition of the random data, but you can use this. Okay, you can use this to fit any kind of equations. Okay, like power form. Okay, modify the number of terms. Okay, and you can check whether this fit is good or not. Okay, so we have multiple options: Gaussian, exponential, Fourier. Okay. Fourier, not very good. Okay, so do you guys have any doubt? Hello.
I think Saurabh, you can move on.
Yeah. Okay. So I will be moving on. Okay. Okay. So this is curve fitting tool. Okay. You can also perform this same function. There is also a fit command. Okay. So you can also use that one also, but that one have any other problems. Okay. You have to specify the type of fit you want. Okay. And this curve fitting toolbox, it has very interactive graph, interactive platform. And if you want to save, okay, just go here and save your session. Okay, so it will be something. Okay, and if I want, you can just get it back. Okay, now you can here load your session from here. Yeah, from here you can load your session. Okay. Now I will move on to the other topic. Okay. So the other topic is optimization problem. Okay. So we come across a lot of optimization problem. Okay. So, so for any situation that it can be expressed as a function of certain variables. Okay. In optimization, basically we try to find out the maxima and minima of that function using the given constraint. Okay. So we can have certain x that have some variables. Okay, x1, x2, x power n, which will minimize this fxn, and then we have some constant here, or we can see this the other term that here we can also see. You can either write it in that form, okay, write it in this form, or you can write it in this form. It has a similar meaning. Okay, so this is a kind of a linear programming problem. Okay, so here you can see that in a form that 800 lb food is used. Okay, and we have their requirement. Okay, that they have to use at least 800 weight of the food. Okay, to a mixture of corn and soybean meal. So this is the this is the condition that has been applied. Okay, and what they are saying is that we have to find daily minimum cost feed. So this is the cost. This is the cost. So using that, this is our objective function. So this will be our objective function. Okay, and this is our constraint. So this is a comment that that it should be at least 30% protein and at most 5% fiber. So if we are trying to specify into quotient problem, then we receive these two equations. Okay, 0.21 x1 minus 0.3 x2 less than equal to 0, 0.3 x1 minus 0.1 x2 greater equal to 0. Okay, and of course x1 and x2, both we should be greater than 0. So we can see that here x1 and x2, okay, are corn and soybean meal. Okay, these are weight of the corn and soybean meal respectively. Okay, so if you have to solve this type of problems, okay, so we can solve this problem in two ways. Okay, so we have okay, you guys are seeing my MATLAB code, right? So we can solve this problem in two. We can solve it in two methods. Okay, so this is the first method. Okay, so here what I have done is I have declared x1 and x2 as a variable as xa and xb. Okay, now it's an optimization problem. Okay, and this is my problem objective. Okay, you guys have seen earlier that this is my problem objective 0.3 x1 plus 0.9 x2. Okay, and this is my problem constraints that xa and xb Yeah.
Excuse me, sir. Sir, can you explain the constraints, sir? Like how the constraints came?
How the constants are formed.
Constraints. Yes.
Okay. See, for any optimization problem, okay, there are some limitations, right? Like the value of x should not be less than 2. Okay, it should
Yes.
not exceed a value of 10, right? This is kind of engineering problem that if you want to manufacture something, okay, so the cost should
Okay.
not be greater than 10,000. Okay,
Okay.
and the material that we will be using should not be greater than this much kg and that much kg. Okay,
Okay.
you can understand, right? Linear programming problem
Yes.
are quite they're used in multiple fields. Okay, like manufacturing, in civil also. Okay, there construction problems you can see there. Okay,
Okay. Okay.
yeah. So this is a very simple problem. Okay, because we don't have much time, and there are courses on optimization, so you should attend
Okay.
those to get
Okay.
complete view. Okay, yeah.
Okay. Thanks.
So yeah, so you have to formulate your constraint. Okay, that xa and xb, summation of xa and xb greater than 800. Okay, and should be then second constant should be less than equal to 0. Okay, xa and xb it should both be greater than 0. Okay, then we can directly solve using this solve command. Okay, so okay, now it is running. Okay, now we have found the optimum solution. Okay, so the optimum cost will be $437.64. Okay, and the value of xa and xb 470,329. Okay, so you can formulate such problem in like for more than more than two variables. Okay, it's very I have used a very simple problem. Okay, so you can solve it for a problem that has multiple variables. Okay, and it should have any, right here only we have only 5 constants. Okay, so it may have more than 10, 20. Okay, so you have to be careful about how you are defining the constraint and the problem objective, and then you can just simply write it here and it will solve it. Okay, so we have one more method that you can use it to solve such a linear problem. Okay, and this is called this is a simplex method. Okay, so here we have to define the equation in a matrix form. Okay, like this a like, so here we I have defined a and b. Okay, and then what will be the upper bound and lower bound of xa and xb. Okay, and f here, this is our objective function. Okay, this is for, so the thing that we have to be careful about, that if we are using this algorithm, if we are using this linear programming algorithm, then it only consider the a equation as less than equal to. Okay, that is why I have to add this here -1 in both side. Okay, for the first condition, that xa plus xb is greater than equal to 800, but for that it has to be written in this format. It is greater than 0. Okay, so I have to write all of the equation in this format. Okay, so we have to write this equation in this format. Okay, that we have to separate it using less than equal to. Okay, so this is our a matrix, then this is our b matrix, and for xa and xb we don't have any upper bound. The lower bound is that it should be greater than 0. Okay, and we have this our objective function f equal to 0.3, 0.9, and we don't have any equal condition that xa plus xb equal to 3 or something. So we don't have, so we just put it as null. Okay, and here I have specified that what the algorithm will be used. Like here, see, this is dual simplex. That means that we will be using simplex method. Okay. Now, see, now we have solved it. Okay. So these are. So this is the solution that we represent. Then after second iteration, we got the solution, and the value of f is same, 437.6471. So this is the same solution that we got using the previous method. Okay. So the both methods are useful. This method is more useful when you have a large number of variables. Okay, large number of variable as well as large number of constraints. So this method can be very useful. This method is we can actually see here, right, how we are writing. But if you are comfortable writing in matrix format, then I think this method will be more useful. Okay. Okay, so this is a very linear solution, problem for a linear solution. There are other methods to solve a linear problem, but these two are more common and very easy. Okay, and for non-linear problems, we use this f mincom, and here we can also use solve. Okay, so here we have used solve here. Okay, so solve, you can use it for linear as well as non-linear problems also. Okay, so let me show you how you can use this solve command to solve. Okay, so see, here I will be using solve to solve the function. Okay. We have to minimize this fxy equal to x square plus y square plus 4xy plus 2y minus 1, and it has a constraint as xy equal to 2, x plus y equal to x square plus y minus 2 square plus less than equal to 2. So this is a tilted eclipse boundary condition. Okay, and for our problem, the initial point will be x is equal to 3 and y equal to 3. Okay, x equal to 3 and y equal to, yeah, sorry, I think it should be minus 3. Yeah, x is equal to minus 3 and y equal to 3. So here, like previous example, I have defined my variables. Okay, x equal to optimal variable x, y. Okay, the same problem is an optimization problem. This is my problem objective. Okay, and this is my constraint, which is a tilted eclipse. Okay, now this is my initial point. Okay, now solve it. Okay, so received our optimization is complete. Okay, we are finding only local minima. Okay, so the value of f, well, so the value of f, okay, comes up to be 1.6924. Okay, and we will get this value at x is equal to minus 0.777, y equal to 0.74. Okay, so you can use this approach to solve multivariate nonlinear programming problems. Okay, and there's one other approach also, this f minimum condition. Okay. Yeah,
Can you explain this title
hello?
ellipse? Can you explain the title ellipse? The ninth line.
The ninth slide.
No. The
Okay.
ninth line in the
This one.
same code. No, ninth line in the previous. Yeah, this one.
Okay, this one.
Yeah. What is this
So this is a
catalyst?
tilt eclipse. So this is a type of eclipse. Okay, that basically when we plot this function, okay, so it will come when we plot this, okay, so it will come as an eclipse, okay, and its boundary condition will be different, okay. So we know the basic equation for a ellipse, right? Ellipse, okay,
Yeah.
and it will be at some angle, okay. So it is not necessary, okay. This is I have adopted from the okay. So you can use any different type of boundary condition. The naming it, you can put it any name, okay. It is named there because it's kind of an ellipse, okay.
Okay.
Okay. So you can try to solve any other. We have any other method also, which is fmincom. Okay. So here you have to define the function x0, which will be our initial point. A, B, A equal to B eq, LB and UB. LB and UB are the upper bound and lower bound. And here we can see, okay, A equal into X and B equal to. So A, AQ and B EQ, this will be the matrix form when this equation are equal. Okay. When in the constant, you will have sign equal to sign only. So from there we can get this AEQ and BEQ. And A and B we will receive when there is a less than equal to sign. Okay. And X, which is our lower and upper boundary condition. Okay. All this is in all of this is in matrix format. So you can have multiple variables. So for the time being, I'm just using a single variable here. Okay. The equation that I'm using is this one. Okay. So here I have written the equation in using anonymous function. Okay. So it will be 100 x2 minus x1 square divided by whole square plus 1 minus x1 to the whole square. Okay. This is my function, and this is x0. Okay. And from here we have this inequality condition. A and B value, you will get our, and don't have any equality condition. So A, AQ and B, AQ, B, EQ, I have not used. And similar to that, LB and UB are provided in question. Okay. If you want, we can provide it, but we have to write it as null vector. Okay. Okay. So either if you want, you can write. If you don't want, you don't write. Now we have found the local minima. Okay. And the value of x are 0.5022 and 0.52489. Okay. So here you can also write your, we can also receive your output here also. Okay. So you have to modify it. So this is our output. Okay. So, you can use you can use similar, you can use these two methods, okay, to perform a lot of automation problems. Okay. We also have this automation toolbox. Okay, like this, we have this curve fitting toolbox. Okay. So we also have this automation toolbox. You can also use this. Okay. So we have seen this, that you can see the notification, right? That this automation tool will be removed. Okay. So you have to be better to solve it using the code. Okay. So you have to provide this function, You have to write it derivative, gradients applied or otherwise, starting point, linear equalities. So the reason why we are not preferring this toolbox is because, see, the constraint, you have to, if you have multiple variables, then you will be having very problem in providing this and filling this value, that you have to fill this a q. Okay, so it will be a lot of values here. Okay, 0 2, because it is a matrix, because it is in a matrix format, so you have to type it multiple times. Okay, other 0 incoming. Okay, so you can do a lot of problems using this automation toolbox. Okay, but my recommendation is that try not to use this toolbox much, because it's not a very it's not, I can say that it's not very simple. You have to write, if for linear programming, if we have 10 variables, then we will have to spend time writing these values, a, q, lower. It will be easier in writing in code. Okay, I think that covers all of the thing. Okay, these are some references. Operation problem, I have used this book, okay, from Operation Research. Okay, you can see this problem, it is there. Okay, and for MATLAB, just Rudra Pratap, getting started with MATLAB. Okay, so
Hello.
If you have any questions.
Hello, can we integrate function like dx by under root a square minus x square?
Yeah, you can do it.
But I have done it. It is not showing the result. It is just writing the integration.
Okay. You are solving
dx over by under root a square minus x square.
You are solving which one? Diff.
Integrate.
You are integrating.
1 by under root a square minus x square.
A square minus
x square.
Okay, so here you have to provide your a also as a symbolic function. Okay, you have to write this variable also. Okay, so I'm getting the variable a10 x divided by root under a square minus x square. Okay. I think this is the standard. This is a standard problem, right? Standard integration problem. Okay. So you can see here we will get our answer. Okay.
Guys, any more doubts?
How does it know we have to integrate with respect to which variable?
So for the time being, I'm just doing simply integration. Okay. So it will just integrating with respect to the last variable. Okay. Yeah. If you have multiple variables, then it is basically a set of differential equation, right? So you can just solve it using that, or you can also specify this from which respect you have to integrate. Okay. Let me try. What does it say? So see here, if we are integrating with respect to a, we are receiving this value. Okay. So if we are not specifying, then it will be from whatever is the last variable. Okay.
Okay, fine.
So, any other questions?
Okay, sir. I think there is no more questions.
Okay.
Thank you for the time. It was great session. So, Javed, are you here?
Yeah.
Yes, I am here.
So, Saurabh, you are saying something?
No, no. I will share this the problem code that I have done. Okay,
Yeah.
I will put it in the chat box.
Okay, and also, I mean, PGNC send the files, and the PGNC will put the files into the description of the YouTube link.
Can you also share the presentation, the PowerPoint?
Okay, I will share the PPT as well as codes to the PGNC, and you guys can share it to everyone. Okay.
Yeah, sure. Sabit, you can move ahead. You're good to go.
So I'll take one more try. Let's see how it goes. So am I audible now and the screen is visible?
Yes, sir.
Yes.
So for the plotting, we will first, I think you guys might have seen this before, but for the sake of completeness, I'll just go through it. So you can plot the data even without writing any code. So the way you do is using the graphical user interface. So here I am taking an X vector. So mostly in the 2D line plots, we plot vectors. There are only two variables. One is a independent variable and another one is dependent variable. So here my X is independent variable and Y is dependent variable. And this is basically I'm plotting function Y equal to X square. So here you can see the X data is in the workspace. So if you click it, you can see the data. It's 201 data points. Similarly, the corresponding Y values. So the very fundamental function is plot. So if I take this plot, so first independent variable X, that is on the X-axis, and the Y is on the on the vertical axis. And if we then click it, you get in this live editor a lot of these options. So you can put X label like this, Y label, and title, and you can also put the legend from here. You can put the grid, and also you can add some annotations. So like if somebody wants to, I don't know how it came, but anyway, somebody wants to add an annotation like next point or something, so that also we can do. So but these options will not occur outside the live editor. So for that, if we select just these variables in the workspace and go to plot, you see we have the same plot function here. Then this pop-up window appears, and here basically we can, if we go to the edit, go to the figure properties, then we get all these options. So if we go to the plotting, yeah, so here also you get all those options. You can choose the color of the line, line style, you want continuous, dashed. Is it okay, or you guys know all these things? Can somebody tell?
Okay, sir.
Is it okay, right? I can tell this.
Yes, yes.
Okay. So there are a lot of options, type of line, and then you can also take the line widths here. So if I put line width 2, the line get thicker, 5 or thicker. And then there is something called markers. So markers is actually identify your data points. So for example, if you want to put O at your data point, since there are a lot of points, it all covered up. So if I decrease it, now you can see these things. If I zoom it, you can also put the legend name, I guess. Oops, it's not coming. But you get the idea. You can explore here. You will have a lot of options. So like X takes, Y takes. I can put the grids from here, X grid, Y grid. Labels, yeah. So the one we put from the live editor, we can put from here. So we have this title and other things. Then we can also put the X label and then the Y label. So if you explore this thing, you can kind of make a very good plot if you want. So this was the plotting with the GUI, and next we will do all these things with the programming method. So this is my cheat sheet. I'll copy some code from here. So here you see I have used this clear CLC. It clears all the data in the workspace, and then I have taken the same X vector, same Y1, and I am plotting X versus Y1, and I am using the next step is you can specify the line, type of line, color of the line, and the marker here, and the line width also in this argument of this plot function. Then I am putting the X label and the Y label. So if we run this section, it gives me this plot. But I want to add one more plot on this. So I take hold on. Hold on is like MATLAB will hold on this plot. Whatever the next data you provide, it will plot on this figure window. So the next plot is, I will just take this code. So here you see I have constructed another variable y2. It's a combination of y1 plus another multiplication with the sign, and then there is new function that I am using. It's y-axis, right? So what it does, it puts the y2 on the right axis, and then I am putting the label, y label, title, and now I'm gonna run this again. So you see, and here also in the last I put the legend. So this, all the things that we did in the GUI previously, we can do those things now in the programming manner. Next thing is in MATLAB, how the MATLAB plots and manages everything. So MATLAB basically uses an object type of language to handle the graphics. So in this object is kind of an identity. So what MATLAB does, it first creates a figure window. So let's go here. Delete this thing. So you see it has created two figure windows in the workspace. It is not showing here, but if we plot it from the command line, let's clear everything. We give it figure 1. Oops. So yeah, if I give it a figure command, so it creates this window that I'm moving on the screen. So this object, figure object, or manages all the aspect of this window. It's a parent. And then what can I do? I can create an axis. Let's say I put
Here you have written a figure and then you wrote comma.
yes.
So like what does that comma signify?
It's just it separates it from the next line, but apart from this, there is not much significant. Let's try with the without the comma. So if we took it like this, yeah.
And why is it showing figure 3? We have given figure 1, right?
Actually, it somehow is remembering in the background the two other figures. It's not able to clear them. That's why it is giving it a next number. But
okay.
To make sure, that's the best practice is you put a number in this. That's how you remember which figure window you will be working. But somehow it's only storing it. It is not making like this.
I think, sir, by writing figure F, we can see the current.
Yeah. I think you are right. So I close out. So now if I go like figure 1 is equal to figure, I give it a name. Yeah. So now it works. It was not able to clear everything in the workspace. So this is the parent figure. And
figure F, sir, figure F.
Sorry? Hello?
You can type figure F, sir.
Sorry?
Yes, sir. You can type figure F for current figure.
Yeah.
Sir, you can type figure F for current figure.
Yeah, you can do that, but what I want to so what it does, it creates a figure window and then assigns it to a handle, which I am calling it fig1 and then fig2. So next I will create an axis. So instead of typing, if I just run this thing. So here it created this. Yeah. So it created an axis in the figure. So initially there is a figure object, and in the figure you can add an axis, and in the axis you plot the things. Similarly, all the text and other things that you add, they are children of this figure object. So we will try to now plot in this axis 1. So you see, we can, this is visible in the figure 1, but we have the figure 1 and figure 2 both in the workspace. But since I have tell it to use this axis 1, and axis 1 is in the figure 1, so it has plotted like this in this one. And next, what we can do, so we can probe this axis. So all the properties of the axis object are in AX1. So if we run it, we can put the grid using this on the figure. So here is it. So if we want to see other properties, we can just, oops. Yeah, so you see in the axis, we have the X limit, Y limit, and you can just change the figure properties from this axis. If you go to the all the properties, you can see more properties of the figure. So these are basically the properties that we changed from the GUI initially. But if you are when you get to process your data and you are kind of making a program, then more often you cannot go to the GUI to plot everything. So you have to write a script, and then it will automatically plot for you. So you just run the button, you have some data, and it will plot. And all the plotting property you can set from this using this axis object. Okay, so next we will create an axis to that. So here I am creating axis 2 and in the figure 1, and then I am changing the position of this thing to another location, and then I'm plotting another data. So let me just comment it, and if I run the section, you see axis 2 has been overlaid on the axis 1 because I am plotting on the same figure window. So what I will do, so I have changed the position of axis 2. So now axis 2 is in the corner. So this was the axis. So this was the parent object figure in which the children object was axis 1, in which we plotted this data. And let's say now we want to plot this data in the zoomed mode in these axes. So how can we do that? So for that, we can write a plot command with the axis 2. So it will plot in the axis 2, and then x axis. So I am taking all the values that are greater than 3. So all the values that are greater than 3 will put here, and then y, I will take all the y for which x is greater than 3, and then I will. So using axis 2, I will put the grid on this figure, and then I will add a title. Let's run this. So you see, this was our initial figure of parent object. Then we added an axis. Its children, and then we added another axis, and then we can make figures like inset, or if we want to zoom something in this way. But knowing this hierarchy is really useful, because then you can just take the handle of this thing, and then you can change all the properties. So it gives you a lot of control on how the things look. You can increase the size, font, and everything. For example, let's say if we want to change the font of axis 1. So font size, if we want, let's say we want 18 points. So you see the font size has increased. Similarly, you can probe all the properties in this way. And so I will plot another graph using this methodology, but I will not write the code line by line. I'll just go to my cheat sheet and copy the things. Okay, so here I will plot the figure that I showed you earlier in the annotation. So I have taken linear spacing points between 0 to 2 pi. I have taken 1000 points. Then in the y, I have put the sign of these points, and then I have plotted them. I use the hold down command to plot another one, the cos, and I have taken this plot function in the PLT handle, and the cos function I am taking in the PLT cos handle, and then I have used hold off to just because I don't want to add more figures, and then I am taking the axis in the AX. GCA gives you the current axis handle. So using the AX, you can put the label. So like ax.xlabel.string. Similarly, y label. Similarly, the title, grid, minor tick, y minor tick, and tick length, legend title, and all these annotation thing you can add using programming. And now the question is, how do I know these things? So these things you can just know by looking the properties in a particular object. So if you want to, let's say, you want to see what are the properties in this PLT cost. So you can just check get PLT cost, and you get all these properties that you can change. So for example, there is a property called marker. So I want to put it on on this plot. So what I can do, I can just go here, PLT cost dot marker equal to, we always give marker in the string. So let's say we want to put a diamond. So you see all the markers have been plotted, but because this figure is really small, we cannot see it. So I'm gonna undock it. So you can see all these markers. Undock it. Remove it. So do you guys have any questions so far? Are you following? Is it too slow, or any comments? Hello?
You can move on.
Yes,
I think no No one has problem with that.
Okay. So next, there are like some really other common plots. So like you can, here I am using the linear axis. So there are other axes that can be used. For example, log axis on the both x and y. So here I am taking the x points in the log space. So what it does, it takes the 15 points between -1 and 10 to power 2, and then I am generating y vector by adding 12, and then it's a new command subplot that we use. So it's like subplot 1, 2. So we want one row and two column, and this is the first one. So I plot this on the linear scale, and then in the another plot I am using the semi-log, where the scale is log in the x. So here you can see this the same data plotted in the linear x scale. So here one division is let's get it out. Here you can see each division is equal. So if we go to 0 to 20, it's same distance between 20 to 40. But in the log space, you see we have given more space between 0.1 and 1, and this division is from 10 to 100. So here the spacing, although it looks the same, it has more weightage. So sometimes if you plot the data in the linear space, the data get because there are more data near some value, so it get all cluttered. So to remove this, we use graphs on the other scales like log, semi y log, semi log x. So these are the other graphs in this manner that you can use. Then there are scatter plots. Scatter plots, they don't draw line, they just plot points. So here I am generating x point, y vector with the points, and then I am using this scatter function. This is the marker size, and I am controlling using this handle, marker edge color and marker face color. And then I'm using this axis handle to control some properties, just to put the label on the x and y axis. If I run this, we get this kind of scatter plot. So there is another example in the scatter plot. So if we have more data, so how does it? So if here I am taking x vector, which is takes 200 points between 0 to 3 pi, and then takes cos of these points and add a random number to this, and then I am plotting the scatter plot. So it looks like this. The C vector is basically gives the color. So in the C, I have given values between 1 to 10, and as the value of C increases, it is coloring those points based on that. Another thing is, if you because all these coordinates are Cartesian coordinates, if you have some data that is in polar coordinates, you can use another function which will plot in polar coordinates. So I am here, I want to plot this function in the polar coordinates. R is equal to sine 2 theta and cos 2 theta. And so I have taken the values between 0 to 2 pi with this delta, and then I am calculating for each theta what is R, and then I'm taking this polar plot. So in the Cartesian, the function is plot. In the polar coordinates, the function is polar plot. If you run it, we get this polar plots. Here you can see the theta values and the r. Next plot is that is quite commonly used is the histogram plots. So in the histogram plot, it basically collects all your data in different kind of bins. So I am taking here the 1000 random numbers and I am putting them into 25 bins and see how it will look like. So what it does, it gives you like, so numbers between 0 to something, how many are there in that range. So these were some common plots in the 2D or basically the vector data. And next we are going to move to the 3D surface plot. So far, if anybody has some doubt or any comment. Hello? Hello?
You can move forward.
Okay.
No
Yeah,
one
yeah, otherwise it feels like I'm speaking alone.
Yeah.
So no, sir, it is very good things, but what happen is that we don't know anything about that. So when I will watch this video again, then it will be beneficial for everyone.
Okay, so you can ask me. I mean,
no, sir, I don't have any doubt.
Like if it's not like it's a stupid question or anything, you just ask. If
no, sir, it is very, very important for us for thesis purpose.
Okay. Okay. Anyway, so far we were plotting functions like we were having one independent variable, but now we have two independent variables. So the function looks like z is equal to f x comma y. There will be two independent variable and one dependent variable, of course, yeah, z. So for example, if we take a function like z equals to x square plus y square, and we take values of x minus 10, 0, 10, and y minus 10, 0, 10. So it gives total 9 mesh points because each x value will be combined with other y values. So it kind of makes a mesh. And then z will be for all those points on the mesh, the z will be evaluated. So you can see how so here I am closing all the figures, then clearing the workspace, taking x 3 points, y 3 points, and then this function from MATLAB is mesh grid. So what it does, it takes the x, y points and creates a mesh or a grid, and then the mesh, this mesh function, it creates a mesh out of these things. So let's first uncomment this thing, run it. So here you see these are 1D data, so only 3 values. Similarly in the y, only 3 values. But when we will run this function, mesh grid function, it creates 2D data of a mesh. So here you see is a 3 row and 3 column vector matrix. Similarly the y, then we can plot using this mesh function. Okay, So you see, we took the x minus 10, 0 and 10, similarly y minus 10, 0 and 10, and this mesh grid function has created this mesh out of these 1D vectors. And this view 0, 90, what it has done, it has made this figure a 2D. So, and next is scatter plot. What I am doing, I am putting these points on the intersection. So next, what it is doing is, so this figure will create a new figure window, and then I am calculating Z based on this capital X and Y mesh grid values that we calculated, and then I am using stem3 function. What stem3 does, it plots the let's first plot it so that it's easier to explain. So stem3 plots all these the green dots in the Z direction. So X and Y are in the 2D plane, and then Z makes the third dimension. And then this I am using this ST3 handle to control this the color and other properties of these objects, and X is handle to put the labels here. So now, I mean, if we increase these points, we only took the 9 points here. So if we increase the points, there will be many points, and all these Z values will resembling to make a surface. So let's see how we can plot a surface. Okay, so if I run this thing, so here you can see this mesh function has kind of added all those vertices to make a surface. So when we will increase the grid, we will see that it forms a really nice surface. So you see, when I increase the number of points, so this surface has kind of took a realistic shape. There is another function to plot the surfaces, that is surf function. So what I did here, I took the delta. I am taking the values of X between -10 and 10. Similarly, the Y, and I am taking the step of 0.3. So it is making 1D vector, and then using mesh grid, it is creating a grid, and then it is calculating the Z values. So here you see all this 2D matrix is coming out of this, and then we can plot using this figure function. The surf function is exactly the same. It takes the same data and does the plotting. So we see it's work. So you see this function, this plot is created by mesh, and this plot is created by the surface. What is the difference between these two? So if we undock it, so we can see that the mesh plot is kind of transparent, so it is not filling the faces in between the vertices, but it is coloring the lines, the grid lines, based on the height, the surface height. But this surf function, it is kind of filling the face, so it is not transparent, you cannot see through. So it's kind of a net, a fishing net, but it is filled, so you cannot see through it, and there are no lines in this plot. But I have put the line to none. Otherwise, if I don't put it, by default it creates lines. So you see all these black lines. So if your grid is too heavy, all your surf plot will look black. So to remove that, you use this S handle, that is that controls all the properties of this surface, and just set the edge color to none. In this way, you can get rid of the black lines and this nice figure. Next, plots that are quite used are the contour plots. So to explain the contour plots, so suppose we have this same surface plot, and we want to represent it on a 2D domain. So here all the lines represent some kind of height. So these like really yellow lines represent that their height is quite high, and the other lines, the bluer it is lower. So it has been created with the surf C function, but most of the time we only use a contour plot, and for that we use two functions, contour and contour F. So if we plot this, so here I am using the same data in every plot that we created. I am using the same data, only I am changing the function. So here I am taking the contour function, the same data, and I am putting this 4 is it means that I want those number of levels in the contour, and then I'm putting a color bar. So if I run it, so you see here I get this nice contour plots. Here each color represents its value. So the yellow means it is quite high, and the bluer means it is lower, the value is less. And I'm controlling the properties with these handles. Another type, if you want this thing also to be filled, we can use this contour F function, and then you can get a contour plot something like this. Then if you want to plot the vector fields, the people who are from, let's say, mechanical engineering or aerospace, you want to visualize the vector, the velocity, which is a vector quantity. So by plotting the vectors, you can visualize it. So here what I am doing, I am taking this data that is already in the MATLAB wind.mat, and I am extracting this data into these variables, and then I am using this function quiver to plot the vectors. So you can see, then I am putting the title, XY label is showing here. So we can see all this, the data that we plotted, X, Y, this is 2-dimensional data. We can also plot vectors in the 3-dimension. So if we take so here I am this X, Y, I am also taking Z here, and the velocity in 3rd direction is W, and then I'm taking a new figure and plotting the vectors. So you can see here it's the vectors are in 3 dimension. You can rotate it from here. You can see the data, visualize it, how the air is flowing. Next, we can see by images, we can visualize some 2-dimensional data. So basically in this C, it's 3x4 vector, matrix, which has 3 columns and 4 vector, 3 rows and 4 columns. And so what this images SC function does, it puts a color on each value. So it's kind of a 3x4 grid, and it puts a color corresponding to each value. So okay, just I'm going to undock it. And then I will open this function, this variable. So here you see the first element 0 is represented by blue, which is the lowest value, and this element 22 is represented by yellow, which is the highest value here. So in this way, if you have 2D data and you want to have a quick view, you can plot it with the images function and get an overview how the data is in the matrix. And then I will load some of the experimental data that I have from our lab to see how this function plots. So let me plot some more code and then we can explain it. So you see this data is basically 3D data. If we go in this variable, we go to row, we see the 3 dimension. So X, Y, and Z. And I am plotting a 2D slice of that 3D data. So basically it's a flame, and the contour is showing the density. So if we put the color bar, we can see the values. So bluer it is, the lesser the density in the flame, and the yellower it is, the higher the density. So what it did, it basically loaded the data 3d.mat file, which gave me this variable. It has the data in the row and the grid, XYZ grid in this variable that I am using to plot. Then I have extracted a slice, the middle slice out of that data. Similarly, I have extracted the grid with the same method, and then I am using this images to plot it, but it is plotting this, it is not plotting this. So why it does this? Because it is plotting the first dimension on this in the rows and the second dimension in the columns. So to see it in the right way, I am rotating the data here by 90 degrees, and then we can see the flame correctly, it's rising up. Next thing, we can see how we can visualize the data in the volumetric mode. So we have loaded the same data, and we will visualize it by taking the slices. So here what I'm basically doing, I'm loading the data and then taking the slice, X slice, Y slice, Z slice. So you see, it's kind of these slices that I'm putting in the 3D domain to visualize my data. And then I'm using this slice function. I'm giving it X, Y, and Z grid. I'm giving it the data and then these slices that I want to see. And then I'm labeling its axes and then title, and then I am controlling its color and other properties to see. So you can see we can visualize this 3D data in the volumetric mode. So if we put it in this way, we can see this is the slice that we extracted. One more thing, for example, if we want to see the surface, it's like the density variation, how it is being done. We want to exactly extract this surface, how we can do that. So that is the final thing. So here I'm creating a new figure, and then I want the surface value to be at 0.9, and I'm taking the isosurface function. It basically connects all the points at those surfaces that I'm assigning with 0.9, and then patch kind of joins them, and then I'm changing some properties like color and edge color, putting the limit on the axis and the label and the title. So if we run it, it gives me surface visualization like this. So here you can see it has extracted a surface out of that data. It's kind of a flame, a surface of the flame that was calculated in the data. So, and these are some of the links that you can refer if you want to know more, and if you forget. I have taken most of my material from here. This data, the 3D data is from my experiments. And thank you very much for the listening.
Thank you, Javed. It was a great session.
Thank you so much, sir.
Guys, any doubt?
No doubt, sir.
What happened, guys?
सर ये अभी इतना समझ में नहीं आया, लेकिन जब इसको वापस देखेंगे ना हम तो बढ़िया समझ में आएगा। और ये वैसे मतलब बहुत इम्पोर्टेंट है हमारे लिए, ये जो आपने चीजें बताई है इतनी अच्छे से, आगे बहुत काम आएगी हमारे।
But अभी you cannot relate anything.
यस, ऐसा कह सकते हो आप, बिल्कुल। अभी इतना पता नहीं चला, लेकिन ये है कि ऊपर ऊपर से थोड़ा बहुत पता तो चला है।
ओके।
तो लेकिन ये है कि सर ये वीडियो जो वापस देखेंगे ना तो बहुत बहुत फायदा मिलेगा इससे।
Which year you are in?
Sir, I am take first year.
Okay, yeah. So once you go to the lab to do research, then
yes
you.
sir, मतलब I am under राजशेखर सर ना, वो MATLAB और Python के ऊपर ही वर्क करना है।
Yeah. Then the data is actually by seeing the numbers you cannot make a lot of sense. तो उसके लिए उसको plot करना पड़ेगा।
यस सर, ये बिल्कुल जो आपने कोड दिए हैं साथ में, तो वो उनको मैं खुद टाइप करूंगा MATLAB में, फिर फिगर देखूंगा तो वो अच्छा लगेगा बहुत।
Okay, so but this is a kind of overview. The MATLAB provides to plot. One other software is TechPlot that people use to plot. That is also good, but if you are working in the MATLAB and you want to plot something, you have to take the data into the TechPlot and then plot it. But if you want to just know quickly anything, you can just use these functions in the MATLAB and see how your data looks.
जी सर।
Okay.
Thank you, sir.
Javed, can you put the files in the chat box so I can download and I will share forward?
Sure, I will put the final file also in the chat box.
On the out of group of the WhatsApp, right? WhatsApp.
On the Slack, right?
Yeah, or Slack or yeah, on the Slack. You can
Okay.
say on the slide.
Okay.
Thank you, Japet. Thank you.
Thank you all for bearing with me. It's been so late.
Thank you so much, sir.
Okay.
Okay. So I'm ending the meeting now.